today's topic, we're going to be talking about including open source solutions in your GIS strategy. So over the past decade or so, open source has become a lot more mainstream. It's less experimentation, and now it's something much more of a strategic consideration for enterprise GIS as well. So we're going to be opening up a nice little dialogue today. Johan's going to join us and guide us through this conversation. So with that, I'll hand it off to you, Johan and Andrew, if you guys want to present yourselves, and then we can jump right in.
Good morning, good afternoon. I'm Andrew Dunlop. I'm the COO at Spatial. I've been with the business for about 7 years. Throughout career, definitely in GIS, I've had quite a bit to do with open source software and take a keen interest in that movement that's been coming for 20 odd years. Interested in the topics today and looking forward to having that interaction.
Thank you very much, Andrew. I'm Johan Nell. I'm CTO, and we've broken the 25-year barrier, so a quarter of a century on the board with Open Spatial. And I'm CTO, so responsible for the strategic direction of the company from a technology point of view. We'll be discussing including open source solutions in your GIS strategy. And what we're looking at is target audience, state and local government officials and utility sector professionals and their service providers interested in the advancement of GIS. We've moved over the years from quite a lot of service providers to far less, and so your options today are basically, do you go with one closed technology stack or do you go with open source in the overall environment? And if I decide I want to go open source because of changed licensing conditions, etc., what is the implications and is it possible to actually go and do that? So we'll be looking at the overall architecture, what is the process you should follow, your standard adherence, and then what's the compliance best practice in modern GIS implementations. Now, combining open source tools with your enterprise database storage is an important part of that. So you always have the option, the very basic one is to go with the file-based systems. But a file-based system, data management in a file-based system is not a very IT best practice way of going about that. That's very much a focus on what we'll be looking at. And we'll set expectations for learning about strategic adoption of the ecosystems. So why does this matter now? If we look at from government policy and open standards, so the first question is, would I be allowed to use open source software? The US federal government mandates fair consideration of open source software in ICT procurement since 2009 and has been encouraged since 2016. So in state level, open source guidelines, typically it's allowed and in certain cases encouraged. For example, California SAM 4984 encourages agencies to evaluate and release open source solutions to promote investment and interoperability. But if there's insecurity considerations, they don't have to release it as open source, but they certainly encouraged to do. And there's a variety of initiatives in the various states, but time won't allow us to go into all of them. Technology trend favor open standards. So you've got the OGC simple feature specifications. So that is, how do I store my geometries, for example, in a database, and how do I interact with it with a SQL language? And so that is one of the earlier OGC or Open Geospatial Consortium specifications. And so instead of storing the database or the geometries in blobs in the database that only your own technology can read, doing it in an OGC compliant way means that any service provider can actually implement that and look at the same data and manage the data in the same way. So rather than locking up the data in silos behind one door, everybody can actually access that data. So that's one of the very important building blocks of Open Spatial and OGC. Then you've got the ISO 19125 for spatial data. So that's specifically the SQL standard, the SQL language interaction. So how do I do inside and outside, all the various queries, etc. And that's implemented on most of the databases. So if you look at PostGIS, if you look at SQL Server Spatial, if you look at Oracle Spatial, and graphs, all of those type of technologies are based on the open systems architecture that you can actually use a variety of tools to access the data. So your strategic technology alignment, your policies and mature technology. So that's the important part of giving a cost-effective GIS government around enterprise systems. That's an important part of that is to look at what is the supported environment, policies, etc., and taking that so you don't have to reinvent the wheel within that process. So what's some of the challenges in government and utilities to take on something like open source? So what is the sector-specific barriers? So legacy GIS and proprietary data structures limit your integration of a variety of systems, and that can increase operational inefficiencies across your organizations. You've got the regulatory and cybersecurity pressure. Stuff that was acceptable 10 years ago certainly won't fly today. And if you're standing still, you're getting behind every day. It is ever-changing landscape, keeping up with the cybersecurity and regulatory environments. So just keeping up with that is quite a big task. And the pace of that is certainly not slowing down, probably the opposite. So in terms of infrastructure and workforce support, so that is one of the important things where open source from a licensing perspective is free, but not from infrastructure and workforce support. So maintaining the critical infrastructure and your mobile workforces with the whole working from home and field, etc., increase your operational complexity. So one of the important things there would be, how do I go about this? Do I do everything on site and have my own staff that manage my open source environment? Or do I outsource some of that and you've got a whole cloud environment? So you've got that continuum of where do I host? Do I do a hybrid? And so we'll go to a bit more detail later on in that. And then start standardization across jurisdictions, to standardize processes across different jurisdictions, add further complexity in that. So that is where a lot of the open standards then come in, whether you use proprietary software or not, to enable the sharing of data across jurisdictions. So a very important thing is a data-first standards-led architecture. Now, when I say data first, what do we mean by that? Your spatial database layer is a very important thing. If the whole garbage in, garbage out concept is the data is the most important thing. The investment that you do in your GIS is not really in the software or the systems. It is in the data move from one system to another. They move across the environment and keeping track of the data. And so keeping track of the data and keeping track of changes in your data is an important part of what you should do. And that is where spatial database comes into the picture. So something like PostGIS or Oracle Spatial, SQL Server Spatial ensure your high fidelity geometry storage and compliance with open standard in the database system that you can actually manage now. That is for your structured vector data. There's other things around raster data that we'll look at slightly different. The second component is, okay, now I've got my data. How do I share this data with everybody? And that's where something like a GeoServer comes in, using OGC or Open Geospatial compliant interfaces such as Web Map Service, Web Feature Service, Web Catalog Service, Web Map Tile Service. So the whole idea with that is that you can actually go and build all of these, make it available, not in a proprietary format, but in a OGC compliant format that all systems can read, and you can actually make it available and you can consume it. So if there's a data from an external system, you can consume that, or you can actually make your data available to the outside world within the normal sensitivity, etc. of data. So that's one of the things to look at. What is our data policies, your data open? And so there's quite a few jurisdictions that have got data sharing arrangements in place. In terms of APIs, one of the things that OGC has done is made API. So this is a RESTful integration. And what it's doing is here's a structure of how you should set out your API. And within that, you can then put in your normal REST components, etc. And within that, part of that is it's typically JSON and GeoJSON for geometries where you can actually share all of that information. And so all of those standards built on top of each other. So when map fit is a raster image, with feature services is vector, and that embeds a variety of formats that you can actually specify. And something like GeoJSON has become the industry standard to do that. And that thing gives you the ability to actually integrate your dashboard, mobile apps, and data pipelines to do that. So that's part of the building blocks. From a desktop GIS format, QGIS is the undisputed king of the open source software, the desktop components. And so, yeah, it's a standards compliant desktop client, and you for editing, cartography, spatial analysis workflow. And QGIS 4 is releasing in, I believe, 8 days now, with an updated, more modern back-end component, QT6, that gives us a lot more security, etc. So the work that goes in something like a QGIS desktop from an open source perspective really makes it possible to actually do a lot of work, and there's a huge ecosystem around that in terms of plugins to provide you the necessary analysis that you would find. What you will also find is that a lot of the industry software would have a new requirement. They would take a piece of open source software and then put that inside their environments. If you look at something like GDAL for data translations, and then you've got the Proj for definitions, for map projections, etc. All of those are actually open source components that's embedded within commercial software. So a lot of the open source stack is actually embedded in commercial software, whether that is a variety of the providers. So that is one of the standard mechanisms. Now, cloud and AI is very much the two different things. So one of the things that you can look at is a cloud assessment framework. So what is the risk in managing a cloud? So how do you go about the cloud? You could sign up with a service provider that you could put your service in our data center, or manage software to one of the top tier 1 cloud providers. So with those, we're talking about Amazon, we're talking about Google, we're talking about Azure and Oracle OCI. Those would be your options there. Now, then you've got cloud optimized geospatial format. We'll throw a lot of terminology around here. COG would be the cloud optimized GeoTIFF. GeoTIFF has been around quite a long time, and there's now cloud optimized versions of that. You've got the Mapbox vector tiles, a much faster way of disseminating the data. And then Stack for spatial temporal asset catalog. So that is your raster imagery and LiDAR and scanned images, etc. That has got both a spatial component and a time component, and that's then a mechanism how you can make that available. So all of those are part of the open standards mechanism. You don't have to reinvent the wheel. There's the standards that you can take off the shelf and go and implement. You can actually, with this, find that. Now, from a secure cloud deployment, that is then typically what you would look at is some of the tier 1 providers, where they have got a lot of from a security point of view, they've got the data access components, they have got the security for the physical security for the building, so you can actually get in there, and so that you can actually within a secure cloud deployment, you can actually get modern format, performant, and standards compliant cloud spatial systems in there. So some of the security compliance, so you've got the ISO 27001, so that offers a comprehensive system in terms of your data confidentiality, integrity, availability. So there's the variety of the different things. Your SOC 2 assurance, that's a security, privacy, and availability. There's the Essential 8 maturity model, so that's in terms of mitigating cybersecurity principles. There's the OWASP principles from a development perspective, where you can then look at building software from the ground up securely rather than trying to add security at the end of it. So that's a fairly fundamental part of that process. So it is a very important part of how to go about that. Now, how do we do the deployment? So that's where you've got the options. You can do it on premise. Now that gives you full control of the entire stack. It's the infrastructure, the people, the data, but it's then your responsibility to maintain that, to check for the compliance, etc. You can do a hybrid environment. We can combine on-prem solutions with cloud scalability, ideal for redundancy and distributed access. So what you can have is, for example, your data on site, but then have a cloud service based on something like GeoServer with distributed data too. And if I then have a component on my website for when is my garbage collection day, or from a service provider, here's a project that we are running, that you can actually see the information, disseminate, that people can see the data that you are working with within your environment, you can make that available to your clients to be able to do that while still maintaining your on-site data, or you can do it in a managed cloud platform. So what that will do is take the open source technology stack. We can do the data editing in the desktop and then distribution. Now, one of the things that we're seeing happening a lot more is then starting to edit the data in the browser as well. And so that is things around open layers, the whole open source and open systems come into that the whole picture again, where you then have that whole stack available to you that you can actually put your entire environment within a managed cloud platform. And then you don't have to worry from an IT perspective, maintaining everything, updating everything. And then in a managed environment, that also means you don't have to worry about upgrades and all the normal project components that you have with that environment. So practical first steps, data assessment and migration. So look at your existing spatial data and look at how we're going to store that data. So do you migrate your existing system across, or do you put it in an open source database like PostGIS? Those would be options that you need to look at. Your service publication standards, so look at Web Map Service, Web Feature Service, OGC API. So with the Web Map Service, what you have is the stylization is already in there, so you can display the maps exactly like you're doing. The Web Feature Service is more of the bare bones graphics, but the end client is responsible for the stylization, OGC API, etc. That's then where the next step comes into, okay, I need desktop, I need web distribution, I need applications that I can either for my external users or my internal users, how I can make information available for that, for those audiences, making that available. And then look at adopting something like QGIS for desktop to reduce your licensing cost, but tapping into the open source community and all the various plugins that's available around that environment that will give you the capabilities that will rival what the big providers can offer you. Then governance and operational standards. So that is very much the process around schema management, your plugin control, your metadata stewardship. So that's one of the things within that environment is if I'm going to say, I've got my central data set, but then I also have my raster data and all of that. Do you put everything in the database, or do you have some file systems? Do you have the stack capabilities to actually work with a variety of different things? And then how do I make that available? So if I now go and publish a lot of apps, let's call it apps, for different people within your organization, one of the things is, how do you keep control of that? So if I have a standardized layer that I use, but I'm now using it in 4 different systems, if I change it in one, does it break something else? If I change my stylization, is it going to impact other people? So that's a fundamental part of having a view of, if I look at something, how do I know what it's going to affect? So if you just have one system where everybody can see everything from one place, it's fairly simple. If you've got a lot of distributed apps, it can become quite a task to manage that, and then updating any of those becomes a much bigger job as well. That's always part of the decision-making process. So if we look at some of the use cases, government and utility examples, local government, so planning, property and assessment data is an important part of that you can do that. If you look at from a state level, cross-departmental spatial frameworks, if you can actually then make your, let's say, the parcel fabric available to everybody within the jurisdiction that you're at, everybody below that, and they can consume that data without having to recapture that. For utility networks, now doing utility networks can be quite complex, but it doesn't have to be. From a spatial database, we've been doing network connectivity in spatial databases for more than 30 years and doing things like network trace and who's going to be affected if this pipe breaks, etc. And from a fiber perspective, that you can then look at who's affected in terms of the connectivity. All of those type of things are possible without a hugely complex system in the back end. So there's different ways of providing you the necessary functionality without always having all the complexity. And then mobile field operations is a very important part, is real-time data collection, but then also obviously offline data collection to enable your decision-making in utilities. You've got the whole Internet of Things happening, where if you've got information coming back from the field, not personnel, but systems that can automatically report back to your environment and into your system from a live environment. So all of those things are possible. So what's some of the common concerns that you find? So there's security, integration, and coexistence. So the security through governance is an important thing. So what is your operational discipline? It's not just a licensing model, but it's making sure your configuration meet key security standards. So that is then, how do you take that responsibility on? Do you do that internally, or do you take that from a service provider? Coexistence with enterprise systems. So open source platforms can exist with the other enterprise system in a standards first architecture to give you the consistency and flexibility. So all the service provider profess OGC compliance. Good idea is to hold them to that, to say, no, I want my data stored in a way that is OGC compliant, that any system can actually access that and make it available within that environment instead of locking it up behind a specific door. Simplified integration. Doing the OGC standard reduce your integration complexity and improving your interoperability. So that's where a lot of the API comes in. We can do that. So how can I talk to all my other various corporate systems, and that having APIs available to facilitate that. So in terms of a strategy roadmap, what we would do is look at a phased implementation plan. So begin by assessing your data quality, your system dependencies and compliance requirements within your current environment. Look at your architecture definition, so data first standards-led architecture, using the spatial database as a core storage component. So that's a very fundamental part. You can do it with a pilot project to validate your concept, build your capabilities, and introduce governance policies and expanding your deployments. Talking to the people is a very important part of that. So your feedback and your security compliance. So having IT, having the user community involved is an important part of that process. So key takeaways: combining open source GIS with enterprise ecosystems give you a flexible, interoperable and future-proof platform. So open source is not going away. Open standards is not going away. And it is an intelligent decision to standardize on the standards. So not doing a new standard, but expanding on what's there from an OGC perspective. So using those standards give you long-term sustainability and compliance with national and state policies. So your security and governance framework, so you've got all the SOC 2, ISO 27001, Essential 8, the frameworks, etc. And then modernization and service delivery. So if you're looking at doing a data first architecture and roadmap, we can actually assist you with that. We've been around the environment for quite a long time, and it's taking the infrastructure and modernizing it and keeping up with what is happening within the environment in today's world of cloud and AI. How do we manage that whole environment? How do you integrate the components of this while keeping security in mind and reducing your technical debt? So, that's one of the things that you always have to do in terms of making sure you're not building your technical debt, but reducing it and improving your services. So we could assist you with that. Thank you very much. Questions or comments? Brett, I'm handing back to you.
Perfect. So yeah, we want to open a space if you guys have any questions or comments regarding the discussion today. So we do have one comment coming in. So it says, web-based data collection tools like Fulcrum export to shapefile formats. So what similar tools are open source? I don't know if you have an answer for that.
GeoPackage would be the open source equivalent. So that is basically a small SQLite database, not necessarily small, but the difference is instead of a file-based system where you've got the shapefile that has got the geometries and the DB3 file for the attributes and some other files and that has to be then zipped up as an overall pack. It is a small database where you can actually put different tables in You can also put raster in there. So there is quite a bit of there that you then have one database file with all your data embedded in there. So GeoPackage would be the relevant open source component for that. That is also widely accepted. I can just maybe add to that. One of the things that we're doing from a mobile perspective is to, when you actually bringing out to say, okay, I'm now capturing the data, let's put that in a file, and now loading it, the file into my system is not the, so we say, the optimum way of doing it. You should actually have a mobile system where you say, yes, my spatial database, where I send that to the various devices, but it can actually come back synchronized and go directly back into my database, obviously with the necessary data acceptance criteria that you are working with. Yeah, that would be, shall we say, a more elegant way of doing it rather than working with files as a file-based export.
Perfect. Robert says he agrees with that. While you're thinking of other questions, I'm going to pass it over briefly to Andrew. I know that he had a couple of common questions that come up as we discuss open source. So Andrew, I'll toss it to you and you can fill in a couple of those blanks.
Yeah, thanks, Brett. So quite often the questions that do come up, and you quite often see this in forums with open source, is GIS with open source at an enterprise level can be quite difficult to manage. But I think one of the responses that we've always got for that is that the beauty of open source is that you can deploy whatever you like. If it's just one instance of QGIS on someone's desktop, just to do some basic spatial analysis, or a full enterprise system that's capable of doing both. The advent of clouds and being able to manage on tier one cloud suppliers, such as those like AWS, OCI, etc., that Johan mentioned, all that can be managed and orchestrated quite easily. There are some challenges around making sure that you don't get version drift, but it's certainly something that can be managed well within a GIS professional scope, with the assistance of IT or with someone like ourselves that can help out with management and deployment on something like that. That often leads into a question around community. So if you're not going with a commercial standard off-the-shelf application and it is open source, aren't you limited with the community? Aren't you then on the hook for training any new staff that come through, etc.? The argument is that you've got to train staff regardless as to whether, and there is a wide community on some of the other commercial applications, but there's equally as wide a community out there now that is on open source and that know the packages well, especially the desktop packages like QGIS for the development environment, things like open layers and the power of what you can do with software and web development with open layers and turf.js is quite remarkable. It's certainly accelerating in that space. That then also leads into the question around integrations and APIs. The advent of APIs have never been easier to produce. So if you want to get into that field in the organization that you're in, or you've got developers in that field, then it's quite easy to get integrated APIs for integrations. We do a series of APIs that integrate with asset management systems. We do build them readily and quickly for whatever the demand is at that particular time, but it's certainly not outside the remit of a small group to be able to do similar sorts of work there. And just harping back on the security side of things, if you do elect to go an enterprise size implementation of open source with the likes of GeoServer, open layers, QGIS, security quite often comes up as a concern. But again, if it is a cloud deployment, the models that's being followed by the cloud vendors are top tier. It would be arguably more sophisticated than any IT department could implement on-prem. So you have that advantage. If it does go back on-prem, then the latest patches are always being patched for any security vulnerabilities. There's active communities in the mainstream open source applications, and that makes a huge difference. So that if there's any pushback from, say, an IT department, there's plenty of reason to circumvent those arguments with what's out there these days. It's quite mature. And probably one of the largest questions that we've had probably over the past 10 years is, why is it so important to get access to your data at the database? What does it matter that it's locked up in some sort of proprietary format that you can only access with a software application? The API access to data is great. It certainly opens it up to other systems, etc. But when you start to do bulk transactions and really big data, etc., having to rely on an API is extremely slow. So when you do get to those requirements where you need to access the database directly for speed, you need that option. At the end of the day, you need that option. We recently worked with a group. We did a consolidation of 2 GIS systems across, they were doing a merger between 2 government authorities. We did a lot of preparation, a lot of planning with the group. And then when we executed the first amalgamation of the data sets, the process ran within an hour. And we're talking millions of records that have been amalgamated. And the comment that came back was that if we'd used, and I'm going to mention it here, if we'd used FME or something like that, that would have taken a week for it to process. So that's when you start to get into some big data type transformations, that's when it becomes very important to still have access direct to your database. So there's some of the common questions and some of the issues that we often address with open source.
I can maybe just add to that, Andrew, is we had a projection change in Australia, and doing the projection changes in the database where we could actually do some pre-calculations, with all of the data, looking at all the relationships and then moving the data accordingly and being able to look at it afterwards, do all of your comparisons and then find out where you've got your problems. We've had different organizations. Some say, no, we've got to recapture our entire data set. That one wasn't only a projection change, they actually redid the whole parcel fabric. And we managed to do all of that programmatically, using the database, doing everything with the database and not taking it out separately into other software and doing all the work and then putting all the data back. In general, the database is not used nearly enough in terms of the capabilities that it gives you to actually do the database management. You don't need to do everything. The front-end tools, you can actually do a huge amount within the database.
Awesome. Thank you guys for that additional insight. Okay, I'm not seeing any further questions. So with that, we will go ahead and wrap up today's topic. We want to thank everybody for attending, and we look forward to welcoming you at our next webinar. So thank you guys very much, and we'll be in touch.
Thank you.
Thank you.